Okay, guys, this calculus lesson is on relative extrema with the first derivative test. So let's go ahead and begin, you guys. So say we had this function over here. Remember f prime derivative equals slope, you guys. So as the function's going down here, the slope is negative. Here the slope is 0, so it's constant. Here the slope is positive. So when it changes from negative to positive, you get what's called relative minimums and relative maximums when it goes from positive to negative. I'm sorry, it's the other way around. So basically, if you go from left to right, when your f prime changes from negative to positive, you're going to get a relative minimum. All right, I'll show you a quick little picture in just a second. So when f prime changes from positive to negative, you're going to get relative max. So here's negative. Let's see how the slope is going down, negative and then to positive. So there's a relative min right here. And where the slope is going positive and it changes to negative, there's going to be a relative max right there. Alrighty, pretty simple, right? So the procedure is to find your relative extrema. So first find the derivative. Okay, and then solve your f prime equal to 0 in the numerator and denominators, and these are going to be your critical numbers. And then make a number line and chart your endpoints and your criticals. Okay, so and then test between the sections of the endpoints and all the criticals on the number line, and make sure you're testing your f prime, not your f. Okay, so whatever your f prime is, and then you can identify. So does it go from positive to negative and negative to positive? You can identify your relative extremas. Okay, so you won't have a picture, but I'll always try and draw a picture after I figure out positive to negative and then from negative to positive. Can you see when it's going from negative to positive? It gives me a relative minimum. From positive and then it switches back to negative. It gives me a relative maximum. Okay, so I like drawing pictures just for me to satisfy my thought on that. So let's just find the relative extrema of this function right here, x cubed minus 3 halves x squared. Okay, and I think the directions in my book says also state the intervals on which it's increasing and decreasing along with the extremas. Okay, so I took the derivative of this. The derivative of this is 3x squared. The derivative of this is 2 comes down, gets multiplied, and then 2 times 3 halves is just 3, and then it's 3x. Okay. Then I set this equal to 0, so I can pull a 3x out of both of those and then set it equal to 0. So it equals 0 and x equals 0 and x equals 1. So now I make a number line chart with x equals 0 and x equals 1, and I test numbers here, a number here, and a number here in f prime, and I'll test it right here. I like testing big numbers, you guys, so I'm going to test negative 10 for this area right here, test a half right there, and then test positive 10 right there. So if I plugged in negative 10, I just want to know, is it positive or negative? I get a negative times a negative. This area is going to be positive. If I plugged in a half right there, 3 times a half is positive. A half minus 1 is negative. Positive times negative is negative. This is going to be a positive. Okay, so then that tells me as it's going up, and then it starts going down, and then it starts going up again. So there's a relative max right there. There's a relative min right there. Okay, so there it is right there. It's going up, and then when it gets to 0, it starts going down, and when it gets to 1, it starts going back up again. So there's a relative max at 0, a relative minimum at 1. And so I'm going to say it's increasing on negative infinity to 0, and it's also increasing on 1 to positive infinity. It's decreasing from 0 to 1. Okay, and then so there's the increasing and decreasing right there. And then for your relative mins and maxes, you guys, you have to plug in the extremas back into the original equation. So I got to plug 0 back up into here. So 0 minus 0, this is going to be 0. Plug in 1. I get 1 minus 3 halves times 1, which is 1 minus 3 halves, which is negative a half. So I get my relative max on 0, 0, and my relative min on, whoops, my underline, sorry, got a little goofed right there, on 1 comma negative 1 half. Okay, pretty groovy. All right, so let's see if I can drag that down reasonably fast, you guys. What was I doing with that? Well, I don't know what I was doing with that. Anyways, I'm wasting time, you guys, wasting video time. All right, so use the same directions for this guy right here. Y equals x to the fourth plus 1 over x squared. Okay, before I take the derivative of that, I'm going to make it, because it's x to the fourth over x squared plus 1 over x squared. So I'm going to separate them up with the denominator. All right, this is much easier to take the derivative of. I wouldn't want to do quotient rules that. Ugh, gag me. Okay, so the derivative of this is 2x. The derivative of this is negative 2x to the negative 3. I have it over here. Okay, I'm going to put it as a fraction, you guys, because I want to set the numerator and denominators equal to 0. So there's the derivative right there. Okay, so now I set the numerator equal to 0 and the denominator equal to 0, and I get plus or minus 1 and 0 for criticals right there. All right, now I can't get 0 because in the original equation it gives me an asymptote right there. X can't be 0. So what happens is this graph is either increasing or decreasing asymptotically at x equals 0. So you can plug it in a calculator and check it out and see what it's doing. It's real easy, and you'll see in just a second, you guys. So I'm going to test. So here's negative 1 for the negative 1, and here's positive 1, and here's 0 right there. Okay, it's still a critical. I just want to see is it increasing or decreasing. So I'm going to plug in negative 10 into f prime. I'll probably plug it in right there. So negative 10. I get a positive over a negative is going to be a negative. I'll plug in negative a half, and I get, when I plug in negative a half, I get a negative over a negative is a positive, and so on, you guys. So it tells me that it's going to be decreasing, it's going down, then it starts going back up again, okay? But remember, right here, there's an asymptote going right up at x equals 0 up the y-axis right there on the graph right there. Okay, and then it's coming down from the y-axis, then it starts going back up again at 1. So that tells me that there's a relative minimum right there, there's a relative min right there, and actually, they're absolute mins. Okay, because it asymptotically goes up forever and ever and ever. All right, so it's increasing on negative 1 to 0, and it's also increasing on 1 to infinity. Okay, decreasing on negative infinity to negative 1 or 0 to 1. Okay, relative mins, and actually they're absolute mins, and there's no relative maximums at that asymptote right there. All right, and if you're in my calculus class and using my Larson's book, which is the 7th edition, I believe, yeah, that would be your homework assignment. Take care, you guys.